So we've done SQL injection, cross-site scripting, command execution, clickjacking, cross-site request forgery in the previous video, so that was the last one. And today we're going into directory traversal. Now, this is actually grayed out because I've completed it maybe a year ago just to get myself. I think I was in a situation where I found a directory traversal vulnerability and I needed a refresher on it. So directory traversal, in this video we're looking into the attacks, so the exercise, and in the next video we're actually going to look into the prevention and then the quiz. The quiz is probably like a minute or so. Now let's go into directory traversal attacks. You need to be sure URLs describing file paths are safely interpreted lest a hacker try to get access to sensitive files on your server. So let's see how a misconfigured server can be a security hole. Websites are made up of two types of files, not file. Those intended to be accessible by the browser, like JavaScript and CSS files, and those that are not, of course. So those that are not. Web servers often route URLs to particular template files or assets on the system. So make sure you understand the keyword route. Typically, the layout of the files on the server mirror the URL structure of the site. A naively configured server can be too permissive about what files it returns. This allows a malicious actor to access files that were never intended for public consumption. Now, let's actually see how. Imagine that you run a website that hosts restaurant menus. So, Foodle from Google. User clicks on the name of a restaurant to download the menu for that restaurant. For example, like this. I'm actually clicking here on the back end, so behind the screens, but it doesn't do anything. So the name of the requested file is passed in the menu parameter of the query string. So in this case, if I would click on the first one, Arachna burger, that's probably lobster burger, something like that. So menu arachnaburger.pdf. Unfortunately, the raw file name is used in the download URL, so an attacker can abuse the menu parameter, so this is the parameter that we're actually abusing, to climb out of the directory that holds the menu PDF. So Trix crafts a URL using relative path syntax, .. to explore the local file system. So .. all the way out into the root directory, and then when you're in the root directory in a Linux system, you actually access etc password. In Windows, you're actually accessing Windows host or something like that, Win32 host or something like that. Since the server does not validate file paths, Trix is able to access sensitive files on the Unix hosted system. So this is actually the output of Trix's ownage. So Trix has tried to access .. all the way into the root directory and all the way into the etc password, and they received the contents of the etc password because the server does not validate file paths. Now you have a go. Enter the relative path .. all the way up to SSL private.key, then you hit enter, okay, and that's actually when you access SSL private key. If you access SSL, etc SSL, you're in etc SSL. See how it changes over here? If you're accessing var, it's var. Maybe they didn't configure it for that. So etc SSL, you're in there, and then private.key, and you're in there. So in this situation, you're actually moving out of the current directory, moving out one directory, moving out two directories. So it's like you would actually say cd. So in Windows, for example, we are in C users Christie. cd dot dot, we are in users. cd dot dot, we are in C. In this situation, you're actually in a Unix system. You could do the same thing with cd dot dot, but when you're actually trying to access something, you can also access it via the relative path. Because considering, for example, let's say I might have in my users a file, let's see, public.ini. So if I go back into Christie and then dot dot slash, maybe just type dot dot slash public.ini, maybe it works, maybe it doesn't. The syntax of the command is incorrect. So not public, but desktop or public. Public.ini, like that. It was desktop.ini. So that's actually, so in Windows it's a bit different. It's dot dot backslash, but in Windows, in Linux, it's dot dot forward slash. So this is actually directory traversal in a nutshell, and in the next video we're actually going to look into the defenses against directory traversals.